This is a machine problem video presentation on Secant method using MATLAB, presented by Video-Geniza. The objective of this video is to implement the secant method in MATLAB. As an example, let us use the equation f of x equals x cubed minus 4x squared plus x minus 10. Using MATLAB, we can solve for a root of the equation with the secant method. Let us divide the MATLAB code into 4 parts for better understanding. The first part of the code initializes the variables and arrays that will be used in the program. This will be used as a counter in the while loop, and at the same time, it will be used in the indexing of the arrays. This will be used for the initial value of the error term, which is in the third part of the code. 6 blank arrays will be created to save the iterated values of x sub 0, x sub 1, x sub 2, f of x sub 0, f of x sub 1, and f of x sub 2, which will be displayed in tabular form when the program is executed. Let us now go to the second part of the code. This line will display a text description on what the program will do. This line will pause the program for 1 second before it clears the screen. This will enable the user to enter the first value of x sub 0. This will enable the user to enter the first value of x sub 1. This will enable the user to enter the terminating condition. This line will compute for the initial value of the error term that will be compared with the terminating condition. This will get the absolute value of the initial value of the error term. Let us now go to the third part of the code, which is composed of the while loop. The while loop will keep on repeating the instructions inside it as long as ER_abs is greater than the terminating condition. This will save the current value of x sub 0 as the nth element of the x sub 0 array. This will save the current value of x sub 1 as the nth element of x sub 1 array. This will compute for the value of f of x sub 0 using the current value of x sub 0. This will round off the current value of f of x sub 0 to 5 decimal places. This will save the current value of f of x sub 0 as the nth element of the f of x sub 0 array. This will compute for the value of f of x sub 1 using the current value of x sub 1. This will round off the value of f of x sub 1 to 5 decimal places. This will save the rounded off value of f of x sub 1 as the nth element of the f of x sub 1 array. Continuing the third part of the MATLAB code. This will compute for the current value of x sub 2 using the parameters x sub 0, x sub 1, f of x sub 0, and f of x sub 1, and then save it to the variable x2. This will round off the current value of x sub 2 to 5 decimal places. This will save the rounded off value of x sub 2 as the nth element of the x sub 2 array. This will compute for the value of f of x sub 2 using the current value of x sub 2 and then save it to variable fx2. This will round off the current value of f of x sub 2 to 5 decimal places. This will save the rounded off value of f of x sub 2 as the nth element of the f of x sub 2 array. Moving on to the rest of the third part of the MATLAB code. This will increment the value of n by 1 and save it to variable n, replacing its previous value. This will assign the current value of x sub 1 to x sub 0. This will assign the current rounded off value of x sub 2 to x sub 1. And then this will compute for the current error term. This signifies the end of the while loop. The code between while and end will continue to iterate as long as the terminating condition is not met. The while loop will end if and only if the terminating condition has been satisfied. In order to present the 6 arrays in tabular form, we need to transpose them to become a column array. This will transpose the x sub 0 array and save it to the variable x sub 0. This will transpose the x sub 1 array and save it to the variable x sub 1. This will transpose the x sub 2 array and save it to the variable x sub 2. This will transpose the f of x sub 0 array and then save it to the variable f underscore x 0. This will transpose the f of x sub 1 array and then save it to the variable f underscore x1. This will transpose the f of x sub 2 array and then save it to the variable f underscore x2. Let us now tabulate the iterated values and display the value of the root of the equation. This will tabulate the values of x sub 0, x sub 1, x sub 2, f of x sub 0, f of x sub 1, and f of x sub 2 for each iteration. This will display the value of the root of the equation from variable x2 underscore r to 5 decimal places. And now I'm going to show you the actual .m file, which is contained in the MATLAB editor. As you can see here, these are the different lines of codes that were presented a while ago. So this is the first part. This is where we initialized all of the variables and the arrays. The second part, alright, and this is the while loop. Alright, so I'm just gonna scroll it down for you to see the actual MATLAB code in the .m file. Alright, I also copied and pasted it to a live script for me to be able to show you the actual output on the right side of the screen. And the bottom part, which is a command window, right? When we run this program or this live script, something will appear on this part for us to be able to enter some values for the values of x and the terminating condition. Alright, so let's proceed with the actual output of this MATLAB code. Alright, so I'm just going to move this up for you to see the things that are going to appear on the command window. Alright, so I'm just going to press this run all button on the top of your MATLAB. Alright, so run all. Alright, so as you can see here, we have entered the initial value of the first integer x0. Alright, so what I'm going to do here is enter a value like, for example, 3. Alright, so that's your x sub 0. And then if you press enter, it will prompt you to enter another value for this is a value for x sub 1. So I'm going to type here 4. Alright, so to simplify our analysis, I'm just going to make I'm just going to input a terminating condition equal to 0.01, and I'll discuss later how the program runs. Alright, so as you can see here on the right part of the live script, so this program will solve for a root of the equation, right? So I'm just going to zoom that in. So when I ran the live script, it showed this line. This program will solve for a root of the equation f of x equals x cubed minus 4x squared plus x minus 10 with a specific terminating condition. right? So I just included that one to signal the user what the program will be all about. All right, so I'm just going to scroll it down, and I'm going to zoom it more so the text will appear larger. All right, so the program has displayed the different values of the arrays. For example, this one we have fx0_r, so it has been enclosed, so there are actually 4 values for that, right? And then we have fx1 _r, right? You have 4 values. You have values for x2 _r, so on and so forth. So in this case, we have 4 iterations for the specific inputs, such as x0 and x1, and for the terminating condition 0.01. So we have 4 iterations, and it will display the value of the root, which is equal to 4.30697. This is the computed root based on the terminating condition. So let's run it again. So run all. Alright. So I'm going to input, like for example, let's say 1 and 4. So we already know the root is 4.30697. Press enter. And then I'm going to input 0.01 again for my terminating condition. Alright, so let's see what will happen. Alright. Alright, so these are the outputs again. So let's count. 1, 2, 3, 4, 5. So actually we have 5 iterations. So the farther the values are from each other, the more iterations we will have. So let's have another example. Alright, so I'm just going to clear this up. So type CLC, clear. And I'm going to right click this one and clear all output. Alright, so I'm going to run all again. Press run all. Alright, so I'm going to input let's say for example 1 and let's say 6. Alright, and then 0.01 again. Let's see how many iterations we have. Alright, so we have 1, 2, 3, 4, 5. I'm going to scroll this down. So there's a lot of iterations going on here. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the farther your values are, the more iterations we will have, because the program is trying to solve or compute for the root. Alright, so the more iterations it will have. Alright, so now let's try a smaller terminating condition, such as 0.001. So let me just clear this up, CLC, and right click this one, clear all output, and then click on run all again. Alright, so I'm going to press, I'm going to select 1 in, let's say 5. But the terminating condition will be 0.001. Right, so that's 1 0 more in decimal compared to the previous example. So press enter. Alright, so how many iterations do we have? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 iterations because we're aiming for the terminating condition of 0.001. So again, you will have more iterations if the terminating condition is relatively small compared to other terminating values.